Streams are a very important concept in today's highly data-intensive applications. In order to work better with streams, akka has provided us with a great actors framework. Now, this framework has already been described and lectured on many other tutorials. So in this one, we simply take a few points, and we already assume that you know the theory of actors and some basics of akka, and of course some basics of streams. And we'll just go through these concepts which integrate the streams, the akka framework, and of course the actors. So without further ado, let's begin. So what we'll cover is first the become, unbecome, and the receive method of actors. We'll go quickly through streams, through persistence, and how we can achieve it with akka, with the finite state machine, when to use it, when not in akka, the remoting, what are its basic building blocks, what do we get from it, and the cluster, which is based upon the remoting. So first, the first concept is the become. So you have an actor and you have some state. Remember that an actor represents an actual visitor or an actual customer. It's an actual identity that exists. It's not just a general class on an object that aggregates a few. You can have an actor that aggregates a few, but usually the recommendation is that if you have multiple customers, then you have multiple actor and an actor for every customer, and this makes it very strong because you can use this customer in like its own thread and do operations of it without the complexity of multi-threading, because it's just a single thread seemingly to you. So if our actor was in one state and we want to move it to another state, let's say our customer was unsubscribed and it's now a subscribed customer, so we move it to the subscribed state, and by moving it to a state we use the become keyword or the become method, which we get by inheriting from akka superclasses, and we simply pass to the become the name of the function which we have defined, the function of the receive with the return type receive, which is the one which is accepting our new events to the actor. So in one case it will be in this example in the blue state, and the receive method will do one type of things, and when it becomes in another state, then we change the receive method. This is both good and bad. This is good because we are able to change the state. This is bad because it's not really clear. When you look at the code, you have like an overloading method. You have multiple methods which each used in a different state. This increases the complexity, but it also eases our architecture. In these states, what I recommend to do is to keep your stuff simple, to keep your DSL small, and we'll talk about it further on. So as we saw, we have multiple receive methods, and for each one it's we are making it come to life on a different state. So the default method, when we want to have the default state, then we simply execute the command receive equals green receive. In this case, we have told our actor your default state, because we simply called it receive, and receive is the default method. Your default state is the green receive. Now, when discussing actors and in general event sourcing, if you don't want to know what event sourcing, I recommend you to read a little bit about it, because we are trusting that you know it. Then in event sourcing, what we are doing is that we are receiving commands. The commands is from the external world. from the external world. The actor receives these commands, it validates the commands. This is the external, like the external world want to mutate our actor. It's trying to communicate with the actor, so it's sending it commands. Our actor receives them, it validates them. Why it validates them? Because it's coming from the external world. You don't trust what's coming from the external world, and then you transfer it you yourself, the programmer in your actor code. After you validated it, you transfer it to events, and the events are the internals events which you now trust. We'll elaborate on this, but what we need to remember from this: commands coming from the external world into the actor, we validate them, and we generate events. With that, we move on to streams. Now, in our big data world, we have fast big data strings coming right at us. What this means is that we would actually be happy if we wouldn't need to deal with the streams. Streams are a limitation of our world. We have a limited memory, we have limited CPU. So we can't look at the whole picture, we can't look at the whole of it. And many programmers treat streams as if it's a good thing, but I actually claim it's not really a good thing, it's just a limitation. I mean, everything at the end is a limitation, but if you could look at the whole picture with no performance penalties and with no additional costs, then you would look at the whole pictures, and I encourage you to do that. But if you're limited, and of course in our today big data intensive applications world, we are limited, we are very limited, so we need to use streams. Now, strings on themselves are very important concepts, and we use them, but we would also be happy not to use streams if we did not, because in this way we could look at the whole picture. Now, when we are talking about reactive streams, then we are talking about the fact that the subscriber is communicating back. It's like the reverse. The event of the stream events is coming from the publisher to the subscriber, but now think of the subscriber communicating back to the publisher and telling the publisher, oh man, I have only 5 empty slots in my buffer, so don't bomb me. Send me only 5 items at max if you have. Okay, so now here the subscriber is asking the publisher to send him the event, and he tells him how much free it is, how much idle it is. This is like the reactive. I mean, this is the pushback. Okay, this is the backoff. I'm telling my publisher, don't bomb me. Now, the way to create the most simple stream is simply, I want to give you the basic syntax, so you see it's not that big deal. You just say source.repeat. In this case, we are creating a repeat of 2 characters HH. We throttle it to emulate the real world with some rate, and we pass it to a sync. It's a little bit reminder, and for a good reason. It's reminding us of storm topologies where we have the spouts. The spouts are like the source, and the sinks is like what the bolts are eventually sending the stream to and processing it. So when you have the stream and you can work with the streams, and the next thing to remember is that when we get a string of events, then sometimes we want to persist them. Now, why would we want to persist them? It's in case of failure. We discuss it. So we have in Akka also a concept called PersistentActor. Now, you don't just inherit from an akka actor, you inherit from a persistent actor. The reason we have such a persistent actors is that if our actor crashed, then we can simply resurrect it. Actually, the actor system will resurrect it, and when we recover from the crash, and we return the state to the actor. So if you had a customer with some balance, after your actor crashed, you can resurrect it and get the balance right away from the state. So we persist the actors to some persistence. Now, the actual syntax for creating such a class, for creating the code of such an actor, is a class MyActor extends PersistentActor. PersistentActor is a class which belongs to akka. Now, what do you save to the persistence? Now, what you actually save to the persistence is the events, not really the state. We can store the snapshot, but what we want to store is the events, and it's reminding us of event sourcing, where we look at our data as a string of events, and not just as a mutable state where you muted the state. So we persist the events so that later on we can replay them. So remember, we had a command. The command was received by our actor, and what you, the programmer, do is that only if the command passed the validation, and so it succeeded passing validation, then you generate the event, and then you persist this event to the B. So you don't persist the commands because command can fail. You don't want to mess again with the whole failures and to become to an inconsistent state. So you persist the event to the B. Now, of course, you can ask, but what if during the processing of the commands and the events, I reached out to an external system? Let's say I reached out to Stripe and processed a payment. Now, this is outside of my actor's string. This is outside of my control. How can I just replay it? So when your actor resurrects, you can, of course, and this is the reason you store the events, you can of course replay the events which were the successful outcome of the commands. So you just replay them one after another. But what do we do with these external outcomes which are out of your hand? So of course it would be best if the external mutations to the external world would be idempotent. Yes, of course it would be great if you could execute this Stripe transaction 20 times, and it would be as if you executed it only one time, and maybe Stripe allows for it. But if it does not allow for it, then unfortunately the answer is that you need to handle all these cases manually. So when you replay the events, you need to have a separate process which is smart and knows what to do with the external mutations and the outcome. Usually when this is described, it's described very plainly and very simplistically. They're saying everything is great, the world is just amazing, you just replay the event and you reach the same state. But it's not correct, and it's important to know it, because you have external services which are not idempotent, and you need to handle them. And not only if you replay the event, also if you had a failure but you reach out to the external system, you need to know how to handle all these edge cases. And it's not that simplistic as most tutorials, I think, show. This is part of why we're doing this video, in order to touch these points. Now, we said we replay and store the events, but we also store and replay snapshots for us to have performance optimization. You don't have to do this, but if you want to be able to recover quickly, then you want to do it. And then when you replay, you first load the snapshot to be your new state, and only then you persist the event. Now, the actual syntax to persist the event is you call the method persist, which is given to you by akka. If you inherited, of course, from the persistent actor, you pass to the persist the argument your event, and the operation, which is the argument to the event. Now, when do we persist the events? We persist the events only first we persist the events, and only then we update our actor state. And why is that? It's because that if your actor failed after you persisted the event, then this would mean that when your actor is resurrected, you replay the event, and you have that event in the store, so you will replay it. And only after that you update the state. This is in order for you to be in a consistent state. And if you didn't, of course, persisted, then your state is in its previous state. Now, the default persistency of actors is a journal to the file system. By journal, this means, of course, an append only, and as an outcome of that, it's very fast. It's appending only to the file system. Now the file system is usually overlooked, but it's actually a very strong storage. In many cases people use DBs. Remember, the file system is one of the strongest storages and DBs. But this is only the default, and if you insist, then of course in production you can change and plug in different persistencies which akka already provide you. For example, you can persist the events and snapshots to Cassandra, etc., and other plugins. Of course you can write this plugin yourself if you have the time. Now, we said that, and I want to repeat it again, we persist the internal events and not the external commands. And each actor, you have an actor, it presents multiple customers, and in order for the persistency to work, you must define an identifier, and you must name it persistence ID. And this persistent ID should be equal to the identifier of your actor class. You can name it my customers, okay? Because this actor represents all customers. It's not John or Stanley, it's customers. And later on you will be able to use it in order to fetch events, and of course when you persist them, it's using this identifier. This is also a good thing and a bad thing, because you need like to remember what is this persistent ID. In the whole of akka system you need to remember many things. You need to remember the methods, the receive. It's a whole API that you need to remember and work with everything. It's not that you implement it alone. Sometimes if you use, for example, Node.js, you have a single thread and you implement your logic. Here you have, it's very opinionated about how it should work. It's both good because it's opinionated, it tells you how to work, and it's bad because you need to remember the syntax and this. Sometimes when you try to make things which are not in the main line, then you can find it's either difficult or you need to read a lot of the documentation, where in other frameworks which are less opinionated, you can just implement it. So it's both, as always, both good and bad. So the method which is called upon recovering of the actor is actually called receive recover, and you need to handle the state update. You need to tell, you need to write as a programmer inside that method, you need to write case snapshot account, then update my state, override in this case my state. Let's repeat again, and we have the 4 steps in the receive command: validate, generate event, persist the event, and of course the last step, update the state. And with that we move on to the finite state machine. Now if you have only 2 states, then you use, as we said, become in order to move between the states. But if you have more than 2 states, things will become more complex. So again, akka actors are providing you with an infrastructure to create finite state machines, which means your actor moves in between states, and in each state it has its different receive methods. And the way you syntactically do that with akka is that you define the class MyActor extends, in this case PersistentFSM, not PersistentActor, and you give it as arguments the state type, yes, not the state value, and the domain event. So you like compose, this is my state type, this is my domain event, and this is my actors, this is my actor. And you have then a method which you need to override yet again is the play event, because in the FSM you have a different method which is called the play event, and over there you get an event, your domain event, you get the input data. It's like your current data. It's reminding us of immutability. You get the data, the transformation or the event, and then you return the outcome data. It's like immutable. This is my new data, and when you return it, your state is updated for you. Okay, so some more syntactic about the persistent FSM DSL, and of course there is a whole DSL for this which we won't cover. You can simply Google for persistent FSM akka, you will see the API. It has a startsWith. StartWith is like, we remember at the beginning when we defined the receive method equals assignment to green receive. So here we tell, we tell startWith where we initialize actually it's not the receive, we initialize the initial state. Here we initialize the initial state with the green, but then instead of becoming, you say when I need to move to a different state, then I move to the green state. So it's replacing the become. I'm moving in between states, and yes, it's actually like the receive method, and then you tell case and move on. So the persistent FSM DSL is that instead of the original method receive, you say startsWith. If you remember, we said at the beginning, we said receive equals green receive. Now we say startsWith receive. So we have a DSL instead of the standard receive method. So you need to remember two things. If you're using become, you're using receive, and if you're using the DSL, then you're using the startsWith. Okay, we have many DSLs, and when you use the when, you use the when in order to receive, and you receive and you change your state. So let's discuss another feature, a very nice feature which akka provides us, and it's the persistent query. Now, what is a persistent query? Well, if you know the abbreviation CQRS, it stands for command query request aggregation, which basically is not related to events. It's not related to event. Many people complex it with the event sourcing, but it simply says, you see, you have the read side and you have the write side. You could implement it with plain Java code. I have my output stream and I have my input stream. Okay, you have the read side and you have the outside. So the persistent query is a new feature which will become stable in the next akka release, which gives you the ability to query the events. And with this, we receive a few methods from the persistent query of akka, which are to get all events, to get all the persistent IDs, and to get events by a specific persistent ID. So we can simply query. It's not SQL, it's not that you can now do complex queries, but you have some basics, and you can build upon it in order to read your data. So you have data stored as events, as sequential events, one after another, and you can query them. Okay, and with that we move to a new topic, which is the remoting and clustering. Now, you have both clustering and remoting inside akka. Remoting is you can think of it as the lower level of the cluster. Cluster is the higher abstraction. Now, in order to support remoting, you need to add this akka remote to your SBT. You need to update your application.conf. So instead of local, you say there, I'm remotes, we are here, hey man, we're here remote actors. You add the hostname and the port of your actors, and then you have like two operations. You have the lookup to look up for remote actors, and you have the create in order to create new actors. So it's like two operations. One, I'm creating a new actor, and another, I am looking up for an actor. Now, when you look up for an actor, then you have like an URL. The URL akka.tcp, the actorSystemName, the hostname, the port, which you defined in the application.conf, and the actual actor name. And this is how you get a handle to the actor. So therefore, This is how remoting basically works. It's very simple. So you can have now your actors spread across the nodes. But what happens if you don't want to manually define all this as you saw? So in this case, you can use the feature which is the higher abstraction of the remote, which is the cluster. Now the cluster is like you have multiple nodes. Each node is hosting its actors, and in between the nodes you have peer-to-peer communication of which nodes are members in this cluster. So this means we don't have a single point of failure, and nodes can join and get removed, and there is no single node which is special. There is, we'll talk about it, but each node can be removed and added, and you define how many nodes you want for this type, and we'll see it, we'll just see it. So we do have actually the leader and the seeder, and the leader is marking the new nodes as up or unsubscribing, and this way you get some callbacks later, as we'll see, to unsubscribe or up, and then you do some operations. It's like the construction and the destruction. So unlike what's other systems, this is again both good and bad. Unlike other systems where you have different microservices, then you can define like I have 3 frontends, I have 3 backends, and I have 4 handlers of this type of roles. So you can have an akka cluster of let's say tens of nodes or even more, but it's one holistic cluster, and in this one holistic cluster you define the roles. It's not like I deploy the microservice of type and it's sitting on whole different machines. Here you have a single cluster with multiple types of nodes. You can claim that today with the Kubernetes and the elasticity you less need this feature because they handle the cluster for you, but this is a very nice concept. In Akka they tend to take things to the extreme of abstraction and design. This is both good and bad. Now, as we said, you have the two callbacks, which is the pre-start when you know when you have your member app marked as app, and the post-stop, which you can implement in order to unsubscribe and to distract yourself. And the onReceive, where you can check explicitly. So when you receive a message, you check explicitly. You can check explicitly your role. For example, am I a frontend or am I a backend? And then based on that, you would tell what to do about this. So that's it. Of course, this was not a whole reference. What we did was just to cover enough topics to get you on the hang of what Akka has for you in case you're already dealing with event sourcing. I'm sure that if you're dealing with event sourcing and you didn't use Akka, you will see that you have re-implemented some of the things that Akka already implemented to you. It's always up to you to decide whether you implement, in which case you will have full control and it's great, or whether you take Akka and you are both limited by its DSL, but you already have someone taught for you how to handle CQRS, how to handle event sourcing, how to persist my items, how to read them. I need already ready-made queries, how to build my clusters, how to assign different roles. So you can take ideas maybe from there into your own custom implementations, which sometimes is very good. So you benefit both your worlds. You both take something which is already made, you implement them, or just use akka actors. And with that, I would like to ask you, please comment if you have any comments or maybe things I said which are not accurate. Please comment on this. So with that, I would like to say, please comment. If you unliked it, click the unlike. If you liked, click the like. And please let me know if you want to hear more lectures. I can do more on math, statistics, physics, history, art, philosophy, which I very much like, literature, and of course computer science and programming. If you have more ideas, then please let me know in a comment. I hope that you gained something from this lecture, and I hope to see you on the next one. Thank you very much.